According to Navarro and McKenna 2020, studies have revealed that the sources of the problem in the Philippine science educations are related to a defective science curriculum, poor capacity for preparation of science teachers in areas of content and pedagogy, faulty implementation of delivery of science education, and the death of a science culture in the country. Filipino students' perceptions have also been indicative of existing problems in science education. Students have viewed science teaching as lacking suitability between materials used in actual classes and tests and assignments. Further, there has been a discrepancy in the way science has been taught in the classroom and the way it has been communicated outside the classroom. Particularly, science education stresses memorization of facts instead of conceptual understanding. Moreover, the assessment of grading procedures have not matched or been reflected of the students' actual learning. In fact, in 2003, the DepEd revised the grading procedures used by teachers, allowing students to pass science subjects without truly gaining their curricular goals. In other words, students have been given credit for success they did not work for. Correspondingly, these have been reflected in Filipino students' low performance in international assessments such as TIMSS and PISA. Thus, the problematic situation of science in the Philippines before this global catastrophe has made it hard for students to demonstrate positive outcomes in science learning. This study aimed to investigate the effectiveness of integration of crossover learning in teaching science to improve the academic performance of grade 4 pupils. Specifically, this study sought to answer the following questions. Number 1. What is the result of the pretest of the participants of the study? And 2. What is the result of the post-test of the participants of the study? And last, is there statistically significant difference in the pretest and post-test of the participants of the study? The concept of crossover learning refers to a comprehensive understanding of learning that bridges formal and informal learning settings. Mainly, this is because all the questions focus on the basis of crossover learning, which means connecting what kids learn in school with situations that are informal, enjoyable, and attractive. That way, truly meaningful education takes place. So, crossover learning attempts to connect academic content and everyday learning. Therefore, it looks to link school work with experiences outside of school. From a motivational point of view, crossover learning is an interesting teaching method for teachers. Linking curricular material with what the students like is a way of awakening their attention and interest in learning. Kids learn certain subjects better if they're taken outside of the classroom. As crossover learning suggests, many school subjects could be more fun if we link them to something practical. Participants were 30 grade 4 pupils of the school who were identified with difficulties in understanding and mastering the competencies in Science 4 based from the pretest. The said pupils were chosen using a non-random or purposive sampling technique. This study used pre-experimental pretest-post design, so the data were collected using a standardized 20-item test that was adapted from Science 4 module. The researcher did not modify the said instrument to get valid and more reliable results in this study. The test consists of 20 questions that assess the participants' academic performance in Science 4 in first grading period. Data shows that the participants' pretest yielded a mean of 2.5 and standard deviation of 1.08. Data shows that the participants' post-test yielded a mean of 19.7 and standard deviation of 0.67495. Findings revealed that after the integration of crossover learning in teaching science among the participants improved their academic performance. Integration of crossover learning in science emphasized the transfer of learning and importance of eliciting prior understanding. Also, this action research showed that if the crossover learning is practiced correctly and thoughtfully, it will be an excellent teaching model which can promote students' higher forms of cognitive domains, which is in coherence with the theory of Bloom's revised taxonomy for cognitive domain. Following our action plan of this study,